Welcome back to this third installment in our data analysis series. Last time we added a regression line to our scatter plot here, and we had Excel calculate the equation for the line of best fit. We're going to do a little bit more advanced work now. Instead of just looking at the gradient value, which is here, we're going to be asking Excel to work out for us the level of uncertainty in this gradient. Now here's what we do. We come down here to calculate the mean value, so the command is average, of the x coordinates. Close the bracket and then enter. I will copy that formula into the next cell beside it, so I'll just paste the formula there, and now I've got the mean x and the mean y value. I'm going to add that data point, that single data point, to my graph, and the way we do it is this. We click on the graph to make it the focus. We go chart design and then select data. We already have one data series. We know add another data series. The x value is this single, and then the y value is this one. And we say OK. We've got our data point there. I keep getting this annoying message about my OneDrive. I'll just try and ignore that and press on. Now, there's the data point. I'm going to select that data point. Sometimes it's a bit hard because it selects the line. So the way to do that is to go to the format, and then on this drop down, we can specify series 2, and then we can go format. Now it's the appearance I want to change, so that's the one that looks like a bucket. I do not want, it's my marker, I do not want it to be filled in. So now that average point is this open circle, distinguishes it from a measurement or a calculated data point from a measurement. Now, that's great. My line of best fit goes straight through there. Importantly, my maximum and my minimum line, my steepest and shallowest, must also go through that point. And this is how we get Excel to help us. We use this 4 cells. Now, these are just labels, the words, to tell me what's going on. Click the top left cell and then highlight all 4 of them at once. It's important that you click the top left cell first. Now we enter the formula LINEST. It stands for line statistics. Open a bracket. It even tells us what we need. We need to highlight the y values. That's this range here. Then put a comma. It wants to know the x values. That's this range here. We put a comma. Now the next 2 parameters are both Boolean parameters, so true or false values, and for both of them, I've always just put true and true because that gives the appropriate analysis. Close the bracket. Now here's a very important tip. Before you press enter, you need to hold down the control and the shift key on the keyboard. I'm holding control and shift, and now I press enter, and Excel puts that formula into all 4 of those cells, and it puts different results in each of the cells. Now that 0.714 is the value of the gradient. That's matching what the regression line said. That number, -25, is the value of the intercept, same. But importantly, these numbers here, which we didn't get before, that's the uncertainty. The gradient of this line, calculated by linear regression, is 0.174 plus or minus 0.002 if I round that one off. Now that's important because that means I'm going to be able to use my appropriate uncertainty values when I do the max and the min line. There we go. My intercept is -25. If you recall from our little theory over here, we expected the intercept would be nothing. Now you might be disappointed that the intercept is -25. Well, for a start, the size of the scale on this axis is huge. So 25 compared to this scale, this range, is not much. And 25, give or take 22, that's pretty close to being the same. So we're missing the origin by approximately our uncertainty. I'm not too concerned by that at all. Now, when I come to doing max and min lines, I need Actually, I think what I might do is stop at this point, and then I'll come back and show you how to do the max and min lines in the next installment. Thanks for watching.